Hi, I'm Mr. D from Mr. D Math, where our programs are set up for kids to say what? When kids say, I finally get it. You know, I get asked all the time about fractions, reducing fractions, adding fractions, multiplying fractions, dividing fractions, subtracting fractions. And one of the things that we notice is that if we showed you a way that could work all the time, whether you were doing numbers, letters, maybe you're in algebra and you've got to do fractions that we call algebraic fractions, what if the same method worked all the time? I bet you would say, what? I get it too. I finally get it. In this video, we're going to take a look at reducing fractions and show you how reducing fractions and multiplying fractions are really the same thing. What? Well, let's find out. Have you ever been told when you're reducing a fraction like 42 over 56 that what you have to do is you have to find it? I'll say it in two ways. The first way is find the biggest number that divides into both, or the more mathy way is to say, what's the greatest common factor, and then divide by the greatest common factor. Well, what if we didn't have to do either one of those, and we could answer both the questions, but after we reduce the fraction? What do I mean by that? Well, we're going to work with something called prime factors. Prime factors, well, here's what I'd like you to do. Think of something that multiplies and makes 42. You're probably thinking 6 times 7. What about something that multiplies and makes 56? And maybe you're thinking 8 times 7. If you notice right now, do you notice that they have a 7 in common? And if I asked you what's the greatest common factor, most people say it's 7. Why? Because they have a 7 in common. But it's not 7. It's not 7, then what is it? Well, let's keep going. What do I mean by keep going? Well, is there another set of numbers that we know that multiply and make 6? And sure, we could say 2 times 3. And we still have a times 7. Now notice 7's a prime number because 7 can only be divided by 1 and itself 7. But let's look down below. What about 8? And I'm going to introduce you to the Mr. D game called the number 8. Every time you hear me say 8, you say what? You say 2 times 2 times 2. And why would we say 2 times 2 times 2? Because 8 is 4 times 2, which becomes what? 2 times 2 times 2. And then we still have what? Times 7. Now what are we going to do? And this is the rule. This rule works no matter whether you have numbers, letters, pictures, whatever it is. We're going to cross out whatever they have the same on the top and the bottom and write down what's left over. Cross out what's the same, write down what's left over. That's the game we're going to play. Let's look and see what we can do. You probably already can tell. There's a 2 on the top and a 2 on the bottom. There's no 3's on the bottom, but there's a 7 on the top and the 7 on the bottom. Well, look at that. We've already reduced the fraction. Why? What's on the top? 3. By the way, notice what this is. When I cross it out, what am I really doing? I'm really saying 2 divided by 2 is like saying 1 over 1. So we're saying, what do we have? We have 1 times 3 times 1, which is 3. In the denominator, what do we have? We have 1 times 2 times 2 times 1, or really just what? 2 times 2. There's 2 2's left over. What did we do? We wrote down the factors. We crossed out what they had in common, and we wrote down what was left over. But what about that greatest common factor? Well, to find the greatest common factor, just look and see, what did we cross out? We crossed out a 2. We crossed out a 7. The greatest common factor is 2 times 7, which is 14. Well, we did it. We found the greatest common factor as well. But wait, there's more. What do I mean there's more? Notice what you see. If the greatest common factor is 14, and we said, find the greatest common factor and divide, notice how we already know the answer. How many times does 14 divide into 42? Well, there's my answer right there, 3. What? It's true. What if I said, how many times does 14 divide into 56? And there it is, it's 4. It's true again. We did it. By finding the reduced fraction first and looking at what we crossed out, which gave us our greatest common factor, we can answer all kinds of questions. Now you might be thinking, but Mr. D, you said it's the same thing when you're multiplying fractions. What does that mean? Well, let's find out. Let's look and see what happens in this example. What do you notice? We have 6 over 16. Well, you probably know that 6 is 2 times 3. And think about 16 like 4 times 4, which is 2 times 2 times 2 times 2. How about 80? 80? I bet you're saying 8 times 10. Wait a minute, did I just say 8? I did. Every time I say 8, you say 2 times 2 times 2. 10 is 2 times 5. Look at all these factors that are looking the same. 81, what's that? Well, that's 9 times 9, which is 3 times 3 times 3 times 3. We have all prime numbers now. Let's reduce. Let's reduce? What do you mean, let's reduce? If you notice so far, what I did was what? Well, I wrote down the factors of each of the numbers, 6, 16, 80, and 81. But you notice there's a time sign between 2 and 3. There's a time sign between the fractions. It's the same multiply sign, which means what? which means that we can start looking to cross things out. So how's it going to look? I'm going to start in the top left corner. Start with my 2. Do I see a 2 anywhere in the bottom? Well, look at that. Right there's a 2. How about up here is a 3? Do I see a 3 in the bottom? Well, over here's a 3. Cross one out on the top, cross one out on the bottom. Notice now, what do you see? Well, I see a 2 and a 2, a 2 and a 2, a 2 and a 2. I bet you're doing this as well already, aren't you? And, well, that's it. I'm done. There isn't anything else. Why? Because there's no more 2s to cross out on the bottom. There's no 5s to cross out on the bottom. And what's left on the bottom is 3 times 3 times 3. What does that give us? Well, we have 2 times 5 in the numerator, which is 10, and we have 3 times 3, which is 9, times another 3, which is 27 in the denominator. That's it. It's 10 over 27, and ding, 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 it's already reduced. How do I know it's already reduced? Well, it has to be already reduced. Why? Because we already looked at what the factors were that were left over after we did what? Wrote down all the factors and crossed out the ones that were the same. You might be saying, hey, I finally get it. But then you might have a question. But does that work with mixed numbers too? When you have an integer and a fraction put together to make a mixed number? Of course it does. Let's show you how. Let's take a look at this where we have 2 and 1/12 times 1 and 13/15. Before we write down the factors, what we want to do are create what we call improper fractions. You've probably heard of improper fractions before, and how do we get there? Well, we take the denominator and we multiply it by the integer, in this case 12 times 2, and then we add on the top number, whatever it is. What are we going to get? 12 times 2 is 24, plus 1 more is 25. So we have 25 over 12. Multiplied by what? Same thing. 15 times 1, and then we're going to add 13. That's going to give us a total of 28. 15 times 1 plus 13. 15 times 1 plus 13. There's our 28, and the denominator stays 15. Well, now we're right back to where we were. What are we going to do? We're going to write down the factors, cross out what they have in common, and write down what's left over. It's really that easy. It's really that easy. You probably know 25 is 5 times 5. I bet you also know that 12, being 4 times 3, can be written as 2 times 2 times 3. What about 28? Well, 28 is 4 times 7, which is 2 times 2 times 7. And 15 is 3 times 5. Let's look and see one more time. Starting in the top left corner, there's a 5. There's a 5 on the bottom. There's another 5, but there aren't any more 5s. Okay, how about a 2? Well, there's a 2 and a 2, a 2 and a 2. There's no 7s on the bottom. There's my numerator. And look at that. Here's my denominator. What do we have in the numerator? We have 5 times 7, which is 35. What do we have in the denominator? We have 3 times 3, which is 9. But maybe in your class or the program you work in, you're asked to do what? Change it back into a mixed number. Can we do that? Of course we can. To get a mixed number, we simply take our fraction 35 over 9 and do the division. How many times does 9 divide into 35? You probably know 9 times 4 is 36. We're almost there. 9 times 3 will give us 27, which gets us on our way to 35. 35 minus 27 is 8. Well, there it is. 3 and what? 3 and 8/9. So we did it. We wrote it as an improper fraction. We wrote it as a mixed number. And how did we do it? Well, we started by getting things into an improper fraction, and then we did our thing. What's our thing? Write down the factors, cross out what they have in common, and write down what's left over. Just like that. Now, maybe you're starting to get into those grades where you're starting to learn algebra. Algebra means letters. Oh my goodness, letters. Wait a minute. Are you saying you could do the same thing with an algebraic fraction when it's got letters in it? I am saying that. We're going to do the same exact thing. Want to see what that looks like? Let's check it out. Here we go. We can see it again, but this time there's letters. Letters and numbers. That's what we call an algebraic fraction. An algebraic fraction simply means what? It's got algebra, or another way to say that, there's letters. There we go. I like the letters. Why? Because they're easy to work with. Let's get to work. Let's start with the factors. Think of 48 like what? 6 times 8. Hey, there's that number 8 again. What's it going to be? Well, we know that 6 is 2 times 3, and 8, we've said it, 2 times 2 times 2. X to the second power means x times x. Well, that's it. That's all the factors in the numerator. Let's do the denominator. 75 with a y. 75 is like putting quarters in a vending machine or a parking meter. Yeah, I need 3 quarters to make 75, or 325. Simple as that. 3 times 25, which means we have 3 times 5 times 5. But we have a y, and only one y. And the reason why there's only one y is if you notice, there's no exponent there. It's like saying y to the first power. What are we going to multiply that by? Well, we're going to multiply it by the second fraction. Let's get to work on the second fraction and see what it's going to look like. 25, you probably know, is what? Is 5 times 5. Piece of cake. Y to the third power is y times y times y. But what about 72? Well, it's 8 times 9. 8, I said it again. 2 times 2 times 2. And 9 is 3 times 3. Then we have x to the third. X times x times x. Oh my goodness, we did it again. What'd we do? Well, we wrote down all the factors. Now what are we going to do? We're going to cross out what they have in common. And what's going to happen then? Then we're going to write down what's left over. And that's our answer. Let's start in the top left corner. A 2 crosses out a 2. How about a 3? Well, I have a 3 in lots of places on the bottom. I'll cross out the 1 right underneath it. How about this? We have another 2 with a 2 and another 2 with a 2. But no more 2s. That 2 is going to stay on the top. That's going to be in our answer. How about the x's? An x with an x, an x with an x. The x's cross out just like numbers. Now we've got 5s. Look, there's a 5 and a 5 and another 5 and a 5. And this time we have some y's. There's 1 on the top, 1 on the bottom, and that's it. Notice what's still left on the top. A 2 and 2 y's. That's part of our answer. 2 times y times y. What about the denominator? Well, the only thing left on the denominator is we see 2 3's. And we see an x. What's that look like? 3 times 3 times x. Let's get our final answer. Here it comes. 2y to the second power over 9x. Oh my goodness, we did it. And how did we do it? Well, we did what we said we were going to do, which was what? Write down the factors, cross out what they have in common, and write down what's left over. And hopefully that helps you understand even a little more about what we say when kids participate in Mr. D Math. They say what? They say, I finally get it. See you next time.